Hello everyone, welcome back to my SDL2 on Xcode series. In this tutorial project, we are going to build the classic snake game on Xcode using C and SDL2. This is episode 10. In this new episode, we are going to build the game scene for us to run the game. Now, last time we successfully draw our menu scene here, and when we have a click button here that we would like to, when we click it, we will go to the game scene as in here. Let me try to click this play button and see the result. And you can see that this is a new scene, and this scene is going to be the scene where we are going to run our game. You can see that for now we only have the background, and the background is some sort of like a grid here. The grids are kind of like alternating in color, and they are in the light color and also the dark color, with some decoration within these cells. Let's see how to make this background for our game scene. To make a scene, we remember that we are going to do this using something called the WT scene head, and that will make a structure into a scene. And in this macro here, there are two defined fields. One is called the name. So in this case, you can see that we call our scene instance to be game scene. And then another field is called methods, where it contains methods to manipulate this scene. And in this case, we set it to be the methods in here. So we have 5 functions: the init function to initialize the scene, the clear function to clean up the memory, the handle event function to handle the user input, and the update function is to update our scene according to the process of the game. And finally, the render function is actually the function that draws on the screen. And let's take a look at other fields within our game structure, the local scene type. In here, we also have a variable map that is of game map type. We're going to look at what is inside this game map now. Let's navigate to game.h, where we define the game map. For now, we have 5 fields within this game map. The row column that will indicate the number of rows and the number of columns within our game map, and then the size of the grid here, and finally there is some offset x and offset y, for which we determine where to draw our map. Let's go back to our background and see the definition of these 5 variables. Let me click this play button again. Now you can see that the first row means the first field here. Row means that the number of rows in this background. Column means the number of columns here. The grid size means that if you look at this small square here, it is the size of the length or the size of this each side in this small square here. And the offset x and offset y is the upper left corner of our background. In this case, it is in here, which is 0, 0. But in some cases, we might have a large screen, and our game map might be small. Then we cannot fill the whole screen in here, so we might have some offset to a location to draw our background. Now let's see how we actually make the background using code. We're going to go into the init function. If we take a look at the init function, it is especially simple in this case because we divide it into 2 small functions. The first one is called the game map init function to initialize the map structure within our scene. If we cannot initialize it, we return false. If we can initialize it, then we are going to use this scene structure to create the background for our scene. And that is the simple logic for the initialization process. And then in order to clean up the memory, if you take a look at our structure, the only resource that we need to manage is this background resource because it is going to be created by this function here, generate background. So we need to check that if we have our resource here, then we need to destroy it before we actually leave this scene. And then we set it back to null. And the render function is also simple. In this case, we basically reset the renderer and clean up the scene. And then we'll draw the background using the offset from our map. And then we determine the size of the background and then draw it on the screen. And that is the basic render function here. Now, for the update and handle event, we are not going to implement anything for this time. We will leave it next time. Next, we're going to go into the details of these two functions in the init functions here. First of all, we're going to see how we are going to initialize the map structure using this GameMap init. If you look at here, the GameMap init function basically do two things. It determines the number of column and row. That's the first thing it does. And then it will determine the size of the each grid. And that is the two most important things it does in this function. In order to determine the number of columns, we're going to use the window width divided by the minimum grid size required by the game. In here, we set it to be 16 as our minimum size for the grid. And for the maximum, we set it to be 40. And you can see also here that we define the maximum number for the row and column as well. Let's go back to the init function and see what we do here. You can see that we compute the number of columns based on the minimum grid size. If the number of columns is bigger than the maximum columns count, we will set it to be this maximum column count. And if the window width is too small to hold even one column, then we return false. You can also set a min column count to define the minimum column we need to actually run the game here. In this case, we just set it to be 0, meaning that we'd like to have at least one column in our game. Now, we do the same thing for the row, but now using the height and also using the maximum row count. After we determine the number of column and number of row, then we can determine the grid size. For example, we can use the window width divided by the number of column to get the size in the perspective of the width. And then we compare it to the size in the perspective of the height and take the minimum of them. Take the minimum. And then if the size is larger than the max grid size that we determine, which is 40, then we just set it to be 40. And that would be our grid size. And you can see that based on this computation, there could be a possibility that our map is actually smaller than our window. In this case, I'm going to set the offset of our map to be computed by these two functions. This basically means that we're going to put our map at the center of our screen. And when we finish computing the offset, we are going to return true, indicating that we are done. And you can see that after we initialize the map structure, the next thing we do is to generate the background. And let's see what we do in the background here. If we already have the background, then we return true. Why we need this when we need to this conditional guard here? Well, because when we play this snake game, we may hit game over, and then we would like to run again. Then we might initialize our scene once again. And we don't want to initialize the background more than once. So that is the reason why we put this conditional guard here, to make sure that we don't do extra stuff. Then if it is null, then we need to generate the background by the following code here. We would like to achieve the alternating grid in color. To do so, we are going to have two sets of texture here, the light one and also the dark one. But before that, we need to create the texture for our background using this Sdl Create Texture function. We have seen this function already in the menu.c file where we create the texture for the menu background. This is basically the same. Now, if we cannot create the background, we will return false. Otherwise, we'll set the texture blend mode to be blend, and then we set the render target to be the background, so that when we draw using this renderer, all the draw operation will be redirected to our background. Now let's see how we actually draw this alternating grid in color. The first set is the light color. You can see that in the first set we have also not only one texture, actually we have two. The texture 1 is actually the default texture for us, and texture 2 is a glass texture that with some decoration. Now we are going to enumerate over all the row, but for the column we are going to start with, say, if I is even, then we will start with 0 in the column. If I is odd, that means if we look at the odd row, then we will start with 1. And then you can see that we do not draw each column, but each other column. And that is the reason why how we can draw the alternating grid. Then we compute the position where we should draw, or we compute the position of the grid that we are going to draw. Then we set default to be our texture number 1, the glass structure without anything in it. And then with some probability, we're going to set it to be our second texture in this set of texture here. So the probability is 20%. To achieve this 20% probability, you are going to generate a random number and modulo 100. And then if this number is less than 20, you will change the default texture to be texture 2. And that is how we get the probability roughly 20 to be the second texture. After we determine the texture, all we need to do is to render the texture at this grid location. And remember, since we set the render target to be our background, the operation here will be ultimately redirected to our background here. That is the first part of the background, that we draw the light color grids. And then we are going to do the counterpart. For this one, we are going to set the texture to be a dark glass. Then for this, when we try to enumerate all the rows, we now need to start with a different column. For this one, we start with I modulo 2, meaning that if you have 0 or have even number, you start with 0. But in this case, we have I plus 1 modulo 2. So if we have a even number, now we will start with actually 1. So that will achieve the alternating grid. The following goals are the same. We will determine the position of our grid and then set the default texture to be the first one. With probability 20%, we are going to set it to be the second one, and then draw the texture. And that are the codes for us to draw the background. Now let's come back to our screen and see the product once again. Now you can see that our background now are some alternating grids, and the first row here has index 0. So, and for the index 0, 1, we have some light color grid, which is in here. And this one, you can see that there's some decoration in it. And that is because when we take the random number and modulo 100, it is less than 20. So it's set it to be the second texture. And that's how we achieve some decoration within our background. Now, that is the background. And you can see that this, when we click the menu button in here, we actually can go to the game scene. How can we achieve that? Well, that is rather simple. If we look at the app.h file, you can see that here we have a function called app change scene, which will change the scene to the input here. If we go to the menu.c file and then go to the initialization now, we can see that the play label have called back to be the play label collect. And now we have one more things here than before. We set the callback data of this play label to be the game scene. So we get the game scene using this game get scene function, which is defined in here, in this game.h here. Let's go back to here. Now let's see how we actually define this play label collect. So it should be here. Here. So you can see that our callback data is actually our game scene. When we click our play label, we first need to initialize our game scene. That will help us to actually initialize the game scene. And then we will change the game scene, or we will change the scene to our game scene using this function here. And that's how we achieve the scene management. Now, you might wonder, where should I put the clear function for this game scene? We probably should put it in the app scene or app delegate here. We can even actually initialize our scene here already. So before that, let me include our game here as well. And when our app is initialized, we should also initialize the game scene as well. If we cannot initialize it, we just return false. And then we will put the a scene clear in this clear function to clean up the memory claimed by the game scene. And that will help us to manage the memory for the game. Now, for the debug purpose, we don't want to go over this click process when we develop the game scene. You can see there. Now, when we try to go to the game scene, we have to click this play button, right? But for our development purpose, we would like to go to the game scene directly so that we can see the result quickly. To achieve this, we can temporarily change the initialization of the current scene to be the game scene. So let me change to the game scene here. And then if we run it now, you can see the game scene directly. So that is the game scene. When we finish develop this game scene, we could change this one back to the menu scene. And that will make it easier for us to do the development. So that is for our for this episode, for us to draw the background for the game scene. Next time, we're going to see how we should code our snake and put it on the screen here. Thank you for watching.